Dear students, today's our topic is progressions. So, see this introduction. You might have observed that in nature, many things follow a certain pattern, such as the petals of a sunflower, the cells of a honeycomb, the grains on a maize cob, the spirals on a pineapple, and on a pine cone, etc. So can you see a pattern in each of the above given example? We can see the natural patterns have a repetition which is not progressive. The identical petals of the sunflower are equidistantly grown. In a honeycomb, identical hexagonal shaped holes are arranged symmetrically around each hexagonal cell. Similarly, you can find out other natural patterns in spirals of pineapple. So now let us see some numerical examples. List of the lost digits, that is digits in the ins place, taken from the values of 4 power 1, 4 square, 4 power 3, 4 power 4 are 4, 6, 4, 6, 4, 6 up to so on. Second, Mary is doing problems on patterns as a part of preparing for a bank exam. One of them in the next two terms in the following pattern: 1, 2, 4, 8, 10, 20, 22. Next, third one. Usha applied for a job and got selected. She has been offered a job with a starting monthly salary of 8,000 with an annual increment of 500. Her salary in rupees for first, second, third years will be 8,000, 8,500, 9,000 respectively. Next, fourth one. The length of the rungs of a ladder decrease uniformly by 2 cm from the bottom to top. The bottom rung is 45 cm length. The lengths in centimeter of the first, second, third up to so on rung from the bottom to the top are 45, 43, 41, 39, 37, 35, 33, 31 respectively up to 31 up to so on respectively. So now can you see any relation between the terms in the pattern of numbers written above? So pattern given in the example 1 has a relation of two numbers one after the other. That is 4 and 6 are repeating alternatively. Now try to find out the pattern in example 2nd, in example 3rd and 4th. The relations between the numbers in each list is constantly progressive. The given list 8,000, 8,500, 9,000, each succeeding term is obtained by adding 500 to the preceding term. So observe this point. We are adding 500 to its preceding term, then we get here 8,000 and 8,000 plus 500, 8,500 and 8,500 plus 500, 9,000. So succeedingly we get the terms. Whereas in 45, 43, 41 up to so on, each succeeding term is obtained by adding minus to preceding term. Now we can see some more examples of progressive patterns. In that one, first, in savings scheme, the amount becomes 5 by 4 times of itself after 3 years. The maturity amount in rupees of an investment of 8,000 after 3, 6, 9 and 12 months will be respectively 10,000, 12,500, 13,623 and 19,331.25. So in the examples above, we observed some patterns. In some of them, we find that succeeding terms are obtained by adding a fixed number, and in other by multiplying with a fixed number. In another, we find that they are squares of consecutive numbers and so on. So in this chapter, We shall discuss some of these patterns in which succeeding terms are obtained by adding a fixed number to the preceding terms or multiplying preceding terms by a fixed number. We shall also see how to find them and how to find the nth term and the sum of n consecutive terms and use this knowledge in solving some daily life problems. Now, history also we have then evidence of found that by 400 BCE Babylonians knew of the arithmetic and geometric progressions. According to the Bayesians, these progressions were known to early Greek writers. So among the Indian mathematicians, Aryabhatta was the first to give the formula for the sum of the spheres and cubes of the natural numbers in this famous work Aryabhatium, written around 499 CE. He also gave the formula for the finding the sum of n terms of an arithmetic progression starting with the pth term. So Indian mathematician Brahmagupta, Mahavira and Bhaskara also consider the sums of the spheres and the cubes. Consider the following list of the numbers 0, 1, 2, 3 up to so on, and the second is 100, 70, 40, 10 up to so on, and third is -3, -2, -1, 0 up to so on, and fourth is 3, 3, 3, 3 up to so on, and fifth is 0, 0, -1, 0, -1.5, -2.0, -2.5. So now here each of the numbers in the list is called a pattern. Given a term, can you write the next terms in each of the list above? If so, how will you write it? Perhaps by following a pattern or rule. Let us observe and write the rule. So in the first one, each term is one more than term in the preceding it. So as we observed 0, 1, 2, 3, 4, here we are the second succeeding term is more than the preceding it. And next preceding term, and next second is also in each term 30 less than the term preceding it. 100, 70, 40. Here 70 is less than that of the 30 less than that of the 100, and 40 also 40 is equal to the 30 less than that of 70. And next second and third one, and each term obtained by adding 1 to the term preceding it. -3, -2, -1. So -3 plus 1 we get -2, -2 plus 1 we get -1, -1 plus 1 0 up to so on. We will get like that. In example, in fourth also, all the terms in the list 3, that is each term is obtained by adding or subtracting 0 to the preceding it. In the same way in fifth also. So in all the lists above, we can observe that successive terms are obtained by adding or subtracting a fixed number to the preceding terms. Okay, please observe this point, students. We are adding or subtracting a fixed number to the preceding numbers to get the successive numbers. Such list of numbers is said to form an arithmetic progression. Now, let us see the definition of the arithmetic progression. What is an arithmetic progression? We observed that an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. This fixed number is called the common difference of AP. Let us denote the first term of an AP by A1, second term by A2, up to so on, nth term by AN, and the common difference by D. Then the AP becomes A1, A2, A3 up to so on AN. So A2 minus A1 is equal to A3 minus A2 is equal to up to so on AN minus 1 is equal to D. Here D is called as common difference. Now let us see some more examples of AP. In that one, A, first one, heights of some students of a school standing in a queue in the morning assembly are 147, 148, 147 up to so on 157. And next, second, B, minimum temperatures in degrees Celsius recorded for a week in the month of a variety of city arranged in ascending order are 3.1, minus 3.0, minus 2.1, minus 2.8, minus 2.7, minus 2.6, minus 2.5. So next, the balance money after paying the 5% of the total loan of 1000 every month is 950, 900, 850, 800 up to so on 50. Now, cash pledges in given by the school to the toppers of classes 1st to 12th class are 200, 250, 300, 350 up to so on 750 respectively. So total savings, last one, the total savings after every month of the every month for 10 months when 50 are saved each month are 50, 100, 150, 200, 250, 300, 350, 400, 450 and 500. So in this all the examples we have the fixed number adding to that the preceding number to get the successive ones. So now let us understand about general term of a AP. Now let us see this. Let A1, A2, A3 up to so on be an AP whose first term A1 is A and the common difference is D. Then the second term A2 is equal to A plus D, that is can be written as A plus 2 minus 1 into D. And the third term A3 is equal to A2 plus D, that is A plus D plus D is equal to A plus 2D is equal to A plus 3 minus 1 into D. The fourth term A4 is equal to A3 plus D, that is A plus 2D plus D, that is equal to A plus 3D is equal to A plus 4 minus 1 into D. So looking at the pattern, observe carefully, we can say that the nth term is simply An is equal to A plus n minus 1 into D. So the nth term of an AP is first term A and the common difference D gives An is equal to A plus n minus 1 into D is also called as the general term of AP. If there are m terms in an AP, then Am represents the last term, which is sometimes also denoted by the L. So finding terms of an AP using the above formula, we can find the different terms of the arithmetic progression. Now, in exercise 6.1, we have in which of the following situations does the list of numbers involved make an arithmetic progression and why? So first one, the taxi fare after each kilometer when the fare is 20 for the first kilometer and rises by 8 for each additional kilometer. Solution. From the given data, the tax fare are 20, 28, 36 up to so on. So your first term is, as you know, A1 is equal to 20. Then obviously the second term A2 is equal to 20 plus 8, that is 28. And the third term is A3, simply 28 plus 8 is equal to 36. So here observe that A2 minus A1 is equal to 28 minus 28 and A3 minus A2 is equal to 36 minus 28 is equal to 8. So the difference of fare for each kilometer is same, that is 8 rupees. So given data is in AP. The second one, the amount of air present in the cylinder when a vacuum pump removes 1/4 of the air remain in the cylinder at a time. Now, to solve this one, let us take the amount of air present in a cylinder is X. Now, from the given data, the air present in the cylinder is X, X by 4, X by 16, X by 64 up to so on. So first the present amount of air is X. Then the vacuum pump removes the 1/4 of that air at a time, that is 1 by 4 into X, X by 4. And next in that from that X by 4 again is removing 1/4, that is 1 by 4 into X by 4, that is equal to X by 16. So like that is removing the 1/4 of the air from that cylinder. So solution, first term A1 is equal to X, second term A2 is equal to 1 by 4 into X, that is X by 4, third term A3 is equal to 1 by 4 into 1 by X by 4, that is equal to X by 16. So by observing these three terms, we can find a2 minus a1, that is x by 4 minus x, that is we get minus 3x by 4, whereas a3 minus a2 is equal to x by 16 minus x by 4, that is equal to minus 3x by 16. So here students observe a2 minus a1 is not equal to a3 minus a2. So the given data is not in AB. And next, third one, the cost of digging a well after every meter of digging, when it costs rupees 150 for the first meter and rupees 50 for each subsequent meter. So from the given data, the cost of digging of a well is 150, 200, 250, 300 up to so on. Now first term a1 is equal to 150, second term a2 is equal to 200, and third term a3 is equal to 250. Then a2 minus a1 is equal to 200 minus 150, that is equal to 50, and a3 minus a2 is equal to 250 minus 200, that is equal to 50. So a2 minus a1 is equal to a3 minus a2. So the given data is in AB. The last one, the amount money in the account every year when 10,000 is deposited at compound interest at 8% per annum. So the above data, it is not a AP, as the difference of interest is not the same for every for the consecutive years, as we know that one. Next. No. So here the first one again, here repeated that one, the amount of money in the account of every year when 10,000 is deposited, already we discussed that one. Then second one, write the first four terms of AP when the first term A and the common difference D are given. So A is equal to minus 2 and D is equal to 0. The given first term A is equal to minus 2, the common difference D is equal to 0. Then second term automatically we can find A plus D, that is minus 2 plus 0, that is equal to minus 2. Third term A3 is equal to A plus 2D, that is minus 2 plus 2 into 0, that is simply we get minus 2. Then the fourth term A4 is equal to A plus 3D is equal to minus 2 plus 0. So first four terms are minus 2, minus 2, minus 2, minus 2. And next. Now A is equal to 10, D is equal to 10. So the given first terms are A is equal to 10, common difference is D is equal to 10. Second term A2 is equal to A plus D, that is 10 plus 10, 20. And third term A3 is equal to A plus 2D, that is A plus D plus D. Then we get A plus 2D. Then here we get A plus 2 into 10, that is that is 10 plus 2 into 10, that is 10 plus 20 is equal to 30. Fourth term A4 is equal to A plus 3D, then 10 plus 30 is equal to 40. First four terms of AP are 10, 20, 30, 40. Now A is equal to minus 1.25, D is equal to minus 0.25. So given the first term A is equal to minus 1.25, the common difference D is equal to minus 0.25. Now second term we know A2 is equal to A plus D, that is equal to minus 1.25 plus minus 0.25, that is equal to minus 1.50. Now third term A3 is equal to A plus 2D, that is equal to minus 1.25 plus of minus 0.5, that is equal to minus 1.75. Fourth term A4 is equal to A plus 3D, that is equal to minus 1.25 plus minus 0.75, that is minus 2. The first four terms of AP are minus 1.25, minus 1.50, minus 1.75, minus 2.00. Now, which of the following are APs? If they are AP, find common difference D and write the three terms. So now, minus 1, minus 3.2, minus 5.2, minus 7.2 up to so on. So the first term is A1 is equal to A is equal to minus 1.2. The second term is A2 is equal to minus 3.2. So third term is minus 5.2. Now find A2 minus A1, that is common difference. Minus 3.2 minus of minus 1.2, that is simply we get minus 3.2 plus 1.2, that is minus 2. And next a3 minus a2 is equal to minus 5.2 plus 3.2, that is simply minus 2.0. So given series is in AP. Now a5 is equal to minus 7.2, that is minus 7.2, that is previous term, and then a5 is equal to minus 7.2. A4 is minus 7.2, that's why A5 is equal to minus 7.2 minus of plus 2.0, that is we get minus 7.5 minus 2, that is minus 9.2, and again minus 9.2 plus minus 9.2 plus minus 2.0, we get again plus of minus minus only, then we get minus 11.2, and A6 once again see that A6 is equal to minus 9.2 plus of minus 2.0, then minus 9.2 minus 2.0, we get minus 11.2. So similarly we get A7 as minus 13.2. Now third one, 3 plus root 2 comma 3 plus 2 root 2 comma 3 plus 3 root 3 root 2 up to so on. So here A1 is equal to A is equal to 3 and A2 is equal to 3 plus root 2 and A3 equal to 3 plus 2 root 2. Then find A2 minus A1. Then A2 minus A1 is equal to 3 plus root 2 minus 3, that is simply root 2. A3 minus A2, 3 plus 2 root 2 minus 3 minus 3 minus of 3 plus root 2. That is A3 minus A2 equal to 3 plus 2 root 2 minus 3 plus root 2 is equal to root 2. Here A2 minus A1 is equal to A3 minus A2. So given series is AP. Now A5 nothing but A4 plus D, that is 3 plus 3 root 2 plus root 2. Simply we get 3 plus 4 root 2. And A6 A5 plus D, that is 3 plus 4 root 2 plus root 2. 3 plus 5 root 2. A7, that is A6 plus root 2, that is 3 plus 5 root 2 plus root 2 is equal to 3 plus 6 root 2. So next three terms are by the table. We can write 3 plus 4 root 2 comma 3 plus 5 root 2 comma 3 plus 6 root 2. Now root 2 comma root 8 comma root 18 comma root 32 up to so on. Now here A1 is equal to root 2, that is A2 is equal to root 8 and A3 is equal to root 18. Now A2 minus A1 nothing but simply root 8 minus root 2. As you know, root 8 nothing but under root of 2 into 2 into 2, that is under root of 4 into 2. So under root of 4 is 2, then we get 2 root 2. Already we have there minus root 2, so 2 root 2 minus root 2 is simply root 2. And next A3 minus A2 is equal to root 18 minus root 8. Root 18 nothing but under root of 9 into 2, that is 3 root 2 minus 2 root 2 is equal to root 2. And again, is by saying above, we can get A2 minus A1 is equal to A3 minus A2. So given series is AP. Now A5, root 2 plus 4 root 2, that is here simply F anything but A4 plus D, that is A4 is here 4 root 2, that is 4 root 2 plus root 2, that is root 32 can be written as under root of 16 into 2, that is 4 root 2, and adding by D, that is 4 root 2 plus root 2 is 5 root 2, just he has written in the reverse order, D plus A4 is here root 32 nothing but we can write it as 4 root 2, that's why root 2 plus 4 root 2 is equal to 5 root 2, and A6 root 2 plus 5 root 2, simply we get 6 root 2, and A7 root 2 plus 6 root 2, that is 7 root 2. So next three terms are 5 root 2 comma 6 root 2 comma 7 root 2. Now fill in the blanks in the given that A is the first term, D is the common difference, and A in the nth term of an AP. Now here we have some sums in this, so let us solve this one. First one, an is equal to a plus n minus 1 to d. We have n is equal to 8, so that's why 7 plus 8 minus 1 to 3, that is simply we get 7 plus 7 into 3, that is 7 plus 21 is equal to 28. In the second, a is equal to minus 18 and d is equal to how much? N is equal to 10 and a is equal to 0. So here an is equal to a plus n minus 1 into d. So an we have here 0, that is a value minus 18 plus 10 minus 1 into d, that is 0 is equal to minus 18 plus 9d, then 18 is equal to 9d, then d is equal to 2. an is equal to a plus n minus 1 into d. An we have minus 5, a plus an value 18, so 18 minus 1, d value minus 3. Then minus 5 is equal to a plus 17 into minus 3. Then minus 5 is equal to a minus 51. Then a is equal to 46. Then fourth one, an is equal to a plus n minus 1 to d. Then an is here 3.6, a is minus 18.9, and d is 2.5. Then substituting them, we get 3.6 is equal to minus 18.9 plus n minus 1 into 2.5. 3.6 is equal to minus 18.9 plus 2.5 n minus 2.5. Then on simplification, we get 3.6 plus 21.4 is equal to 2.5 n. That is, on left side we get 25 is equal to 2.5 n. Then n is equal to 25 by 2.5. Then we get n is equal to 10. The last one, an is equal to a plus n minus 1 to d. An is equal to 3.5 plus we have a n value, that is let us see later this one, somewhat difficult, some 105, n value 105 minus 1 and d value 0. So here n value 105, d value 0, and a value 3.5. Thus, by substituting this, we get simply an is equal to 3.5 plus 105 minus 1 into 0. Then an is equal to 3.5 plus 0. Then an is equal to 3.5. So students, I recapped all the easy sums in this video. So let us discuss and again clearly all these sums on board or on a paper. I will explain each and everything. So this is for practice purpose. So make a notes all these sums and be practice well. Okay, all the best. Thank you.